for hydrocarbon emissions is 3.4 to 3.7 microns on the infrared scale. So there's only 3/10 of a micron on the infrared scale that actually detects hydrocarbon gases. It's capable of rapidly scanning large areas. When we first started using the camera, it hard to use because you had to train your eye to see what you were looking at and where normal gas leaks occur. So on a compressor, if you were going to do a pre-scan for a compressor to see what they're going to do on a PM later, it was taking us up to 2 hours. We can probably scan a compressor right now in less than 10 minutes because you know what your eye is looking for. Emissions are seen on the screen as black or gray gas. It depends on the color palette of the camera. We've always dealt with a situation of somebody stealing the camera. Well, we've come to find out that it comes in a real nice Pelican case. They'll open it up and look at it, and they'll probably think it's an old Beta camera and throw it away and steal the Pelican case. So when you look through the lens, it looks like a little black and white film. That's the capability of turning it from black background to white background.
So you carry it now and tell us that?
Exactly. So these emissions are seen when you look at them as a black and gray smoke. Digital record and real-time images for hydrocarbon emissions. We hook the camera to a digital recorder and then record usually our leaks to actually verify where they are, pinpoint them, and give you a spot to see where the leak is. Because a lot of time when you go in and find a leak, you don't know where it is. And the best thing about the camera here is you can come back and prove that you fixed the leak after your PMs are done. Of course, that's a documented pinpoints and a reshoot to verify the corrections for your LDR reductions. Okay. Facility inspections for emission reductions. We use this on tanks, hatches, seals, inardos for VRU enhancements, compressor operations for proofing PMs, gas pipelines. We've actually gone out in the field and walked the field and found leaks coming just right out of the dirt. You'll see the gas coming out of the ground. You know, as far as pipes, I think we had one buried 8 foot. You still found the gas coming right up out of the ground, walking through the field. Flares and vents, gas-operated controls, liquid level controllers, dumps, fittings, flanges, tubing fittings, meter runs. Anything that you've got gas process going to, the camera will look it over right quick and see if you've got any leaks. Other considerations associated with the IR gas finder are commissions on new equipment and facilities, regulatory agencies actively using this camera to identify leaks. They do have this camera mounted on helicopters and are flying over facilities and are asking people to refigure their VOC calculations. Now, I know this for Texas, and up in Wyoming, they're also using it to go out and investigate facilities. So agencies do have this, and they are using it. Emission reduction yields dollar values associated with savings. Okay, Danny. Let me talk a little bit about the dollar savings on it. Very rarely have we ever taken this camera out to any one of our areas and not paid for the camera. That's a huge savings. So every visit we usually save $80,000 to $100,000. This is a list of the detectable gases: benzene, ethyl benzene, heptane, isoprene, methane, MEK, BTEX, any one of these right here. You could go look at your glycol dehydrators and see what they look like, and then see if you have the opportunity